Hi students, we were solving electric field due to one-dimensional charge system. In previous videos, we simplified electric field due to straight long wire. Then we obtained electric field due to a curve. Now in this particular case, we want to find out electric field produced by a thin ring which is uniformly charged on its axis. So see here, suppose this is one XYZ coordinate system and we have a ring of uniform charge and radius of that ring is suppose A. We are placing this ring in YZ plane here in this YZ plane in such a way that its center is at the center of coordinate system. That means axis of the ring will be along the x-axis, and suppose we want to find out electric field at point P which is at distance x from center of the ring. So here if charges are uniformly distributed and suppose total charge present on it is Q, then we have to start with a small segment of charges. So here we are taking this particular point which is present on y-axis and we want to find out electric field due to it at point P. So here direction of electric field will be this one. Suppose this is electric field DE. Now here we have taken angle theta, so this angle will become theta. That means we can divide this DE component into two segments. One is DE cos theta and another component will be DE sin theta. Now if we obtain small charge dq on the ring which is on positive y-axis, then similar type of component we can obtain on negative y-axis also. So here charge will be similar to this charge dq. So if we find out electric field due to this dq charge over here, then this electric field will be in this direction. So this is also DE segment. Now this angle is theta, so this angle should be equal to theta. That means this is also theta. So if we divide this electric field into two perpendicular components, then first component which is along the axis is DE cos theta, while another component which is perpendicular to axis is DE sin theta. So if we want to simplify these two electric fields, then here see that sine components are opposite to each other. So these two components will cancel each other and here cos component will be added. अब जैसे हमने ये दोनों पॉइंट को ऑब्टेन किया और उनके साइन कंपोनेंट कैंसिल हो गए, सिमिलरली सपोज वी आर ऑब्टेनिंग अ पॉइंट ओवर हियर, देन एट एग्जैक्टली ऑपोजिट पॉइंट वी विल गेट अनदर पॉइंट एंड अगेन देयर इलेक्ट्रिक फील्ड्स perpendicular components will cancel each other and their parallel component will be added. That means whatever electric field is obtained at point P is due to parallel components only. So if we write total electric field due to it, so electric field at point P is along axis of coil. It is always along axis of coil. Now what is that electric field? E is equal to integration of all DE cos theta components. So first we have to find out DE component. DE is small electric field produced by this segment. So if we consider this charge as dq charge, then DE electric field will be equal to K into dq upon R square. R is distance from here to point P and this will be root of A square plus X square. So R square is here, A square plus X square. This is value of DE and we also need cos theta. So if we find out cos theta here, cos theta is equal to ratio of adjacent side, which is x upon hypotenuse, which is root of a square plus x square. So finally, if we put these values here, then dE is k into dq upon x square plus a square into cos theta is x upon x square plus a square 1 by 2 power. So this will become k into dq into x upon x square plus a square 3 by 2 power. Now see here, a is constant because a is radius of this ring. K and x is also constant here. This is our P point where we want to find out electric field. So if point P is fixed, then distance from center of ring to point P, which is x, is also fixed value. So K, which is constant, x is also constant, and x square plus a square raised to 3 by 2 is also constant. So in integration, only dq will be there. So if we integrate dq, that will be equal to q, and q is total charge present on the ring. So finally, electric field is equal to kqx upon x square plus a square raised to 3 by 2, which is in the direction of axis of the ring. So if we take axis of the ring as positive x-axis, so we can write caret I here. So this is electric field due to ring on axial point. Now we can use this equation to find out electric field at center of ring also. So if we find out electric field at center, so we are taking first case here, case 1, at center of ring. For center of ring, x will become 0 because P point is now not here, it will be at point O. So x will become 0. If we substitute x is equal to 0 in our first equation, substituting in equation number 1, then E is equal to kq into 0 upon 0 square plus a square 3 by 2. So this will be equal to 0. That means electric field due to uniformly charged ring at its center is always 0 value. Now we want to find out electric field at far away point. That means this x is very large compared to radius a. So we are taking second case, at far point. That means here x is very large compared to a. So when we consider that x is very large compared to a, then x square plus a square will be nearly equal to x square only because a is negligible. So if we put over here, then from equation 1, E is equal to kqx upon, this will be x square plus a square is tends to 0. So this is x cube. X and x cube we can cancel out. So we'll get kq upon x square. Direction will remain same. So this is electric field due to ring at far away point. And see this formula. This formula is like point charge system, kq upon r square. That means when point is far away, this ring behaves as a point charge. Okay. So this formula indicates that as distance increases, electric field should decrease. So at almost infinite distance, electric field will become 0. At center also, electric field is 0. So here, electric field is starting from 0 and at infinite distance, it again becomes 0. That means initially electric field should increase and reaches to the maximum level and then again it will start decreasing to the 0 value. So we'll try to find out a point where electric field becomes maximum. So it may be over here or any point. So we'll try to find out value of x where electric field is maximum. So we'll try to obtain a point where E is maximum. Now what is electric field? It is E, if we write only magnitude, E is equal to K Q X upon x square plus a square raised to 3 by 2. This was value of electric field. Now whenever we want to find out maximum or minimum of any particular function, then its differentiation with respect to variable must be 0. So here variable is x. So to find E maximum, dE upon dx, differentiation of electric with respect to position x, must be equal to 0. That means d dx of k q x upon x square plus a square 3 by 2 should be equal to 0. If we differentiate it, k and q are constant, so we are not considering them, that will become 0. So d dx of x upon x square plus a square raised to 3 by 2 should be equal to 0. So here we have to apply division law of differentiation. So we'll start differentiating square of this term in denominator. So x square plus a square 3 by 2 square, that will become 3. Now x square plus a square raised to 3 by 2 into integration of numerator, integration of x with respect to x will become 1 minus, now x will be as it is, into differentiation of this term x square plus a square raised to 3 by 2. So while differentiating, 3 by 2 will be in multiplication, 1 power less in x square plus a square term, that will become x square plus a square raised to 1 by 2 power. Now differentiating inside, x square will be again differentiated as 2x plus this will become 0, and this whole term is equal to 0. So this, if we take in multiplication, that will be 0. So x square plus a square raised to 3 by 2 is equal to, this term is negative, we are taking on right hand side, and here 2 will get cancelled, x into x, that is x square into 3 into x square plus a square raised to 1 by 2 power. So if we take this 1 by 2 power in division, then 3 by 2 minus 1 by 2 is 1. So here x square plus a square will be 3x square. So finally 2x square is equal to a square. So x will be equal to a upon root 2 positive or negative. That means electric field will become maximum at distance a upon root 2 on either side of ring, on axis of the ring. So these are the points where electric field is maximum. So we obtain 2 points, one on right side and one on left hand side. Now if we want to find out that maximum value of electric field, maximum value of electric field, what will be this value? So now we have already value of x here. If we substitute value of x in equation of electric field, so E maximum will be equal to kq into x is what? A upon root 2. A divided by root 2 divided by x square is a square by 2 plus a square whole 3 by 2 powers. So this is kqa upon root 2 into a square plus a square by 2, that is 3 by 2 a square. and whole raised to 3 by 2 power. So this is k q a upon root 2 multiplied by 3 raised to 3 by 2. This is 3 root 3 upon 2 raised to 3, which is 8 divided by root 2. So this is 2 root 2 multiplied by a cube. So 1 a is cancelled. Root 2 will get cancelled. So finally our maximum value of electric field will be equal to, this is k cube, 2 will be in multiplication, so it is 2k cube upon 3 root 3. 2k cube upon 3 root 3, and in division it is a square. So this is maximum value of electric field. So here we obtained the point where electric field is maximum. Also we found that value. Now if we see the variation of electric field with distance in form of graph, then suppose we are taking x-axis, that is distance, and this is electric field. So at origin, when x is equal to 0 point, electric field is also 0. At a upon root 2 point, electric field is maximum. Similar way, at a upon root 2 negative point, electric field is also maximum but in negative direction. And finally at infinite, electric field becomes 0. So if we see the variation here, electric field should decrease from that point, and in this range electric field should increase from 0 to maximum level. Here also electric field should increase to 0 to maximum level, and from maximum to 0 again. So electric field varies from 0 to maximum on either side. From maximum value it starts decreasing and again becomes almost 0. So this is electric field due to one ring, uniformly charged ring on axis of that ring.